The second air conditioning process that we're going to take a look at is that of heating and cooling with a slight modification. That is where we can either humidify or dehumidify the air. So it's a minor complication over what we just took a look at. Okay, so again what we'll do, we'll begin with a schematic of what it is that we're talking about. So we have our standard air conditioning duct, inlet state 1, air is coming in at temperature 1, specific humidity 1, relative humidity 1. And then we have our heating or cooling coil. And so this could be Q dot in or Q dot out. And that takes us to an intermediate state, state 2. And then what we have is we have our humidification system, basically just spray nozzles that are injecting either water or steam into the airstream. And here we have mass flow rate of water in. So we have water flowing into our system. And finally, the air will exit, and we'll call that state 3. It will be temperature 3, specific humidity 3, and relative humidity 3. So that is what our schematic looks like. What we're now going to do is we're going to take a look at the mass balance equations for both air and water, and then we'll take a look at the first law applied to this type of a system. So beginning with air, and this is quite straightforward. What we have is mass air at state 1 equals mass of air at state 2 equals mass flow rate of air at state 3. So not much going on. The flow is moving through. We're not adding or removing air. For water, what we have is mass flow rate of water at 1 plus mass flow rate of water being injected between 2 and 3 is going to equal the mass flow rate of water at state 3 coming out of our system. And we can replace the mass flow rate of water. Remember, this is the moisture being carried by the air. So we can replace it in that term there using the mass flow rate of air multiplied by our specific humidity. And then again, we can do the same thing for the mass flow rate leaving the system. So recasting it in terms of mass flow rate of air, so that would become our water balance equation. And finally, for energy, so applying the first law, so that would be the first law. Now, in terms of inlet, what is coming in is going to be the air and the steam. Let's assume we're using steam. And then exit is just the air and water vapor. So in order to account for the steam, we need a way to have the enthalpy for steam. So let's assume that we are injecting steam in this particular case. And for that, what you would do is you would get your water in, the enthalpy of that, you would get that from the steam tables. And for that, the enthalpy value will be the saturated liquid value at whatever temperature you may say that it is coming in at. So that would be the way that you could get the enthalpy for the water flowing in, provided that you're considering it to be steam. So that is how you can handle a case of either heating or cooling with humidification or dehumidification. And the last thing that we'll look at in the next segment is that of evaporative coolers.